Welcome back. This is Mr. Hassan's Maths channel. I'm now going to be answering questions from the February-March 2024 International A-Level Cambridge 9709 paper. This is paper 1, variant 2. And I'm going to go through these questions one by one, separate videos for each question so that I can save the questions according to topic as well as paper. And I'm going to take my time and go through them, not just talking through the mark scheme, but actually answering the questions and trying to explain the basis behind the answers to go into a bit of detail so that students who weren't able to study properly during the term, for whatever reason, they had got a chance to catch up now. So we'll start with question number 1. Here we have an integral, which is a type of integral which is kind of coming up more recently. We have an improper integral where we have one of the limits is infinity. All right, so sometimes you get a limit which cannot go actually into the equation, cause it to be undefined, so you have to deal with that. Sometimes you get a limit which is infinity, so you have to deal with that in a particular way. So we're going to go through this now. So first of all, this expression, we want to get it ready for integration. So we have our limits. We're going to write this as 2x to the power of minus 2. We're going to integrate that with respect to x. Now, if you remember, if you want to integrate something or differentiate it, you have to prepare it for differentiation integration. Any x terms that are in the denominator have to be written in the numerator. So here we're using the law of indices that 1 over a to the power of n can be written as a to the power of minus n. Okay, this is, using the laws of indices, negative indices, it can be written as reciprocal. So that's where that comes from. Now we are ready to integrate this. Okay, so to integrate this, what we're going to do now is we're going to basically add 1 to the power and divide by the new power. So we're going to get rid of the integral sign. We'll have this square bracket now. So this is going to be 2x to the power of minus 1 divided by minus 1. Okay, and we got limits of infinity and 3. Now, one of the things I actually like to do is take out the constant. So I'm going to take the constant out. I'm going to write this as, in fact, I can take minus 2 out because there's a minus that's going to be in there as well. Take that out. And this will be 1 over x inside here between infinity and 3. So I can take out the constants. I'll take out the minus sign, okay? And then I can deal with this as it is. If I didn't do that, it's perfectly fine. I just like to do that. I like to take, in fact, I could have even taken out the constant in the beginning. I could have taken out this constant and wrote this as integral of x to the power of minus 2 with respect to x, with the 2 outside. And then the 2 could have been outside here as well. Okay, perfectly fine, no problem. I can write like that. And then I would have got this as well, taking out the minus 1. Okay, so now I'm ready to substitute the values in. So I've got minus 2 times. Now I'm going to write it as 1 over infinity minus 1 over 3. Now, 1 over infinity, now the limit of 1 over infinity, okay, or the limit of 1 over x, you could say, as x tends to infinity, is going to be equal to 0. Because as you have something which is, if you have a denominator that's getting bigger and bigger and bigger, you have 1 over a really huge number, it's going to become really small eventually. So the limit as x tends to infinity of 1 over x is equal to 0. So I can say that this is going to be minus 2 times 0 minus a third, which is going to be minus 2 times minus the third, which is going to be positive 2/3. So there's the answer to question number 1. Pretty simple, okay? But we have to know how to deal with this infinity bit, okay? If it's 1 over infinity, that's going to become something really small. If it's 1 over 0, that's going to be something really big. That's going to tend to infinity. This is going to tend to 0. All right, so we should understand how to deal with such questions. Okay, so that's question number 1. Pretty simple. I'm going to save this as a separate video. So other questions dealing with other questions from this particular paper will be found in the playlist that will appear over here. Other questions dealing with integration, I'll put them in the playlist over here. I'll have a separate playlist for improper integrals so that you can, those students who want to see those type of questions on their own, I'll put a playlist just for that over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.